Section 7.3 is on hyperbolas. The hyperbolas are the weirdest of the three, and the definition is not at all intuitive. The hyperbola is the locus of all the points in a plane such that the absolute value of the difference from the two foci is constant. So if you pick a point and you go from this focus to this focus and you subtract those two distances and you take the absolute value, it's going to be the same as any other point on that graph. If I go here and I take this distance minus this distance and the absolute value, it's going to be the same. If I take this point down here and I go from this point to this focus and I subtract those two distances, it's going to be the same. It's not something that is all intuitive, okay? So, parts of a hyperbola. You have the two pieces. They're not like parabolas, but they are rounded and they are symmetric, so that is helpful. Those are called branches. You are going to have two linear equations that are going to be your asymptotes. You have this imaginary center in here. You have your two vertices, and you have your two foci. Then you have some imaginary stuff that we don't even graph, we don't even draw it, but you need to know it in order to find the equations. The first one is your transverse axis. This is from vertex to vertex. Okay, so from vertex to vertex, the distance is 2a. So that means from vertex to center, your distance is a. From your asymptotes to your vertex, and then down to your asymptotes, there is this imaginary little box that gets created. So this distance is 2a. This distance of this imaginary box is 2b. That is what is known as your conjugate axis. Okay? So the distance from the center to this imaginary line is b. Let's take a look at what the graphs would actually look like. Like I said, you're not going to graph any other axes, the transverse axis, the conjugate axis. You're going to have these two axes graphed. You're going to have your foci, you're going to have your vertices, and then you can absolutely graph the center because that's going to be where your two asymptotes are going to intersect. The equation, if it's horizontal, looks like this, okay? We have this relationship with a squared and b squared. A squared and b squared are no longer greater than or less than one or the other. They can go either way. But what happens is if it's horizontal, the x squared will be positive. Notice there's a minus sign here. And if it's vertical, the y squared will be positive. Notice that a squared is underneath the positive one. B squared is underneath the negative one, okay? So with ellipses, this is a plus. With hyperbolas, this is a minus. We've got all this information. The one new piece is going to be these asymptotes, these linear equations. You're going to have two of them to find. You're going to take y minus k equals b divided by a times x minus h, and y minus k equals negative b over a, times x minus h. Notice if it's horizontal and if it's vertical, that b over a becomes a over b. They switch, okay? So make sure you get all this information written down on your cheat sheets so that you have it, so it's ready to go for the rest of the section.